Hi, good evening, guys. So today's session is going to be packed with data processing and feature engineering with real-time examples and interactive discussions. So our goal is very simple to explore, understand, and go together. So we'll start the session. So data pre-processing and feature engineering. So basically, what do you do before cooking vegetables and why? Can anybody answer?
Can you say one more time the question, ma'am?
So the question is on the screen itself. So what do you do before cooking vegetables? Why?
Basically, we need to wash the vegetables and make it clean for cooking.
Yeah, that is true. So feature engineering and pre-processing are like preparing ingredients before cooking itself. The raw data is noisy, inconsistent, and unstructured. So basically, the quality input is the better model, so better predictions. The more the quality is better, the more better the model will be, and the more better predictions it will make. So, key definitions for pre-processing would be: pre-processing means making clean data usable, and feature engineering means creating better input features to improve model performance. So, data pre-processing, that is cleaning plus transformation, that means handling missing values, common in real-world data, survey skips, sensor failures, options, remove fill with mean median mode, or use advanced mutation. So, I have a question: why might you use median over mean? Answer to this. So basically, the mean is sensitive to extremely high or low values, that is outliers. I'll explain what outliers are. Do you guys have any idea what is outliers?
Yes, ma'am.
Okay. So a single
The,
very yes, please go ahead.
the unwanted data, which is completely different from what we wanted, like noise, which is apart and having a lot of difference with the actual data.
Sorry, your voice is cracking.
The unwanted data is an outliers.
Okay, got it. So the median, which is the middle value, remains stable even if the outliers are present. Suppose there are incomes in a data sets that would be 25,000, 27,000, 26,500, 30,000, and 1 lakh. So the mean would be the sum of the sum of everything. That would be approximately, that is heavily skewed by the outlier. So medium would be 27,000. So we use median when the data is skewed or contains outliers, especially in features like income, age, or house prices. So basically, outliers are the data points that are significantly different from the rest of the data values in a set. They lie far outside the normal range and distort statistics like the mean, standard deviation, or model performance. Suppose these are exam scores of 100. So 75, 78, 80, 82, 79, etc. So mostly the scores are between 75 to 82. But the score 30 is much lower and could be an outlier. As you can see, the most scores are between 75 to 82, so they are in a normal range, and other two are 82 and 99, that is in higher rate, and 30, that is an uncommon, so it is in a low range, that is an outlier. So why outliers are important? Because they can skew the mean, affecting scaling and imputation. They can mislead models, especially sensitive models like linear regression or KNN. Sometimes they carry useful info that would be fraud detection anomalies or rare events. So, how can you detect it? You can detect outliers using box plots, Z-score, or IQR method. So now we'll be proceeding to removing duplicates. So why do you think removing duplicates is essential? Can I have some answers? Why do okay?
Basically, we should remove the duplicate values for the because it can occupy more storage and more space, and it will delay the modeling part of that data.
Okay. So basically, duplicate rows can bias the model. So why duplicate rows can bias a model? Because duplicate rows reinforce the same data points multiple times, causing the model to learn patterns unevenly. This is like telling the model the same thing over and over. It can give extra weight to duplicate data. As a result, the model becomes biased toward the repeated patterns. It may overfit to those patterns and underperform on new data. So we'll proceed with an example. So we will be creating our data sets with duplicates. I'll share the screen now. So at first, we will create a data set with duplicate values. That would be the data would be like what we will be consisting is like age, salary, and purchase. So the age column, as you can see that there are three duplicated values. In the salary column, there are three duplicated values of 80 and two duplicate values of 60. So in the purchased column, there are duplicate values for one, that is 5, that is target variable, and for 0 it is 2. So So as you can see the output. So in the column number 3, there is a duplicate of row number 0. In column number 4, it is the duplicate of row 1. And column number 5, it is the duplicate of row 2. And in column number 6, there is another duplicate of row 2. So basically, this means that class 1 purchased appears more often due to due to duplication. This artificially inflates the importance of the purchase 1 pattern. Now we'll proceed to encoding categorical data. So the example would be gender, male and female. So you guys have an idea about, right? Encoding categorical data. What is encoding categorical data according to you? So basically, encoding categorical data refers to the process of converting categorical values, which represents categories or labels, into a numerical format, so they can be used in with machine learning models. Yes, that is correct. So at first, for Yes, that is correct. One is hot encoding and another one is label encoding. So can you differentiate between one hot coding and label encoding? So basically, label encoding means that converts each category into a unique integer that is suitable for ordinal data, can unintentionally impose ordinal relationship on nominal data. And for one hot encoding means it creates binary column for each category that is suitable for nominal data, prevents models from assuming any ordinal relationship. So we'll proceed with an example. At first, we will create a sample data frame that would be on the basis of gender, city, and priority. So, post that, we will be doing the step 2 will be the label encoding for binary column that would be gender. So, step 3 would be one hot coding encoding for city nominal category. Step 4 would be label encoding for ordinal column that is priority. Priority order would be low, medium, and high. So the map order is like priority order. So as you can see the output, we have three categorical columns that is gender, binary male female, city nominal slash multi category that would be Delhi, Mumbai, and Bangalore. So priority is ordinal that would be low, medium, and high. So gender column is binary mapping that would indicate that male turns to 0 and female turns to 1. Why? Because it is binary. A simple 0 to 1 mapping is enough. So one encoding is a method used to convert categorical variables like city, color, brand into a numerical format that can be used by machine learning algorithms. City column one hot encoding that would be df is equal to p dot get underscore dummies df comma columns is equal to square bracket in quoted that would be city comma drop underscore first that is true. So the original categories are Delhi, Mumbai, Bangalore. One hot creates new columns that is city Delhi. City Mumbai. Drop first true that drops one category Bangalore to avoid multicollinearity. So if city is equal to Delhi, the city underscore Delhi is equal to 1, city Mumbai is 0. So if city is equal to Mumbai, city underscore Delhi is equal to 0, city underscore Mumbai is equal to 1. So if city is equal to Bangalore, both are 0 baseline case. So what is ordinal mapping? Ordinal mapping, also called as ordinal encoding, is a method of converting categorical variables that have a natural order into numerical values. Unlike one one hot encoding used for categories with no order, ordinal maps preserves the ranking between the categories. Suppose you have a column education level. At first, it is high school batch, then bachelor's, then followed by master's, then PhD. So this is a clear order that PhD is the greatest of all. At first, this is in ascending order. So everything gets placed in ascending order. So then the priority column, that is ordinal mapping. So this encodes priority based on level, that low is 0, medium is 1 and high is 2. Why? Because there is a natural order in priority, unlike cities. So the final output is like this. So the use methods in this scenario is, the method is dot map. So use case is binary or ordinal. For example, the gender and priority have used this. So get dummies, second would be one hot for nominal. Example is cities. So label encoder is optional for automatic label to number. So now we'll proceed to skitlearn. So skitlearn is an open source machine learning library for Python. It provides simple and efficient tools for data mining and data analysis. And it is built on top of key Python libraries like NumPy, SciPy, and Matplot library that are used for numerical operations, and SciPy is used for scientific computing, and Matplot library is used for plotting and visualization. So the key features of skitlearn, that is at first classification. Which category of an object belongs to? That is example spam detection and image recognition. So regression, predicting a continuous valued attribute, that would be stock price and for forecasting. Clustering, grouping similar instances, that would be customer segmentation. Model segment, comparing, validating and choosing parameters and models. Example would be grid search and cross validation. So we will do an example for this.
Ma'am, are you sharing the screen?
Yes, actually, there is some glitch. Wait, I will just do it again once again. Is it visible now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Just wait a second. So the accuracy is 1 point. So I hope the screen is visible, right?
Yes, ma'am.
So the score is 1.0. So now we'll proceed to feature scaling. You can go through the code for 2 minutes. So now we'll proceed to feature scaling. So basically, feature scaling is a technique to normalize or standardize the range of independent variables, that is features in your data set. Many machine learning algorithms like KNN, SVM, logistic regression on internets perform better and faster when all features are on a similar scale. So why is scaling important? Scaling is important because without scaling, the model may treat salary as more important just because of its larger numbers, even if it's not predictive. So there are different type of scalings, that is min-max scaling, standard scaling, robust scaling. So min-max scaling is used when distribution is not normal. The formula is listed over here. You can go through it. And standard scaling is used when data is normal, Gaussian. And robust scaling is used when outliers are present. As I have discussed what outliers are. So we'll now proceed to feature scaling. I'll give you an example for feature scaling. So at first we will create a sample data. The data that we'll be using will be age and salary. Age range will be 22, 25, 47, 52, and 46. Salary range would be 25,000, 27,000, 90,000, 1 lakh, 10,000, and 85,000. Then we would import the data frame data. Then the step 2 would be applying min max scaling. So as I have discussed, when min-max scaling is used, when the distribution is not normal, so that's the reason we are using min-max scaling over here, since the data that we are using is the distribution is not normal. So now we'll be using post that standard scaler is used. So here is the output data. The original data, as you can see, and after min-max scaling, the output over here, and this is after standard scaling. So in third step, we are applying standard scaling. So we use standard scaling when the data becomes normal, that is Gaussian data. So situation is like features in different units. Then we'll use min-max or standard. That the features that have outliers, then we'll use robust scaler. Algorithm sensitive to distance or KNN, SVM, logistic regressions. Then we'll use different thing, and then tree-based models. In tree-based models, scaling is not required. So feature scaling ensures fair weightage across features, essential for distance-based model, gradient-based optimization. So basically, choosing scaling method that depends totally on based on the presence of outliers, data distribution, and model type. So as you can see, at first the salary data was not in a proper distribution, so that's why we used min max. Post that, we used to transform the data by applying standard scaling. Please go through the code. Now we'll proceed to feature scaling. Sorry, not feature scaling, feature engineering. So what is basically feature engineering? So basically, feature learning is the process of creating new input features or modifying existing ones to improve the performance of machine learning models. So at first, it means handling missing values. Descriptions would be fill or drop nans, encoding the categorical data, convert text to numbers, feature transformations that would include log, power, binning, scaling. Feature creations, new features from existing ones, date time features, extract year, month, weekday, etc. Text processing, tokenization, TDF, TF, IDF, etc. Feature selection, keep the most relevant features. So the feature creation, basically feature creations means date that would extract the year, month, date, weekday. So domain specific features in e-commerce, that means number of previous purchases days since last purchase. That would extract that. So what
Ma'am,
is yes,
you please show the last slide
yes, please.
before this.
This one.
Yeah. What's actually doing there?
So
Can you?
basically yeah, sure, sure. Wait. So basically, feature creation means to extract the date, year, month, day, or weekly. You can see the output over here. Wait. Sorry, now you can see the output over here. So basically, it means to extract the date features that would include the date, year, and weekday. So in this, the age is extracted, salary is extracted, and the date, year, and weekday is extracted. So we have used this code. Now we'll proceed to that is binding discretion. So binding is also known as discretion, is the process of converting continuous numerical values into discrete categorical bins or intervals. So why do we use binding? We use binding to simplify data for better interpreting, reduce the effect of outliers, capture non-linear relationships, prepare the data for models that don't handle continuous data well. Some rule-based or algorithms. Age into groups that would be bins would be 0, 18, 35, 60, 100. So labels are teen, young adult, senior. Different age groups that would be. So the group are so we want to group the ages into different categories. So 0 to 18, that would be child. 19 to 35, that would be young adult. 36 to 55, that would be adult. 56 plus would be senior. So ages are 12, 18, 22, 35, 47, 55, 67, 80. So we are using pd.cut that would be fixed with binning, that would fix. क्या बकवास हो गया। Now the screen is visible, right?
Yes, ma'am.
So as you can see, so we are using 8 that are 12, 18, 22, 35, 47, 55, 67, 80. So now we are defining the bins and labels that are bins are 0, 18, 35, 55 and 100. So as in the previous slide, I have categorized it. Labels are child, young adult, adult, senior. So now we are applying now we are applying binning. So age groups are, so this is the output for the above data set. As there are 4 categories that are child, young adult and senior. So this is the following output. Okay, then we'll conclude the class then. Rest other topics will be discussed in the other class with examples. Thank you.